Engineering Solutions webinar. And we're getting started right now. We'll give it one more minute. The meeting is being recorded, as the technology tier tells us. Welcome, everyone, and thank you for joining today's webinar hosted by USTMA, the U.S. Tire Manufacturers Association, in collaboration with the Tire Recycling Foundation. This is our first in a series of webinars featuring perspectives from diverse subject matter experts and visionary leaders who are driving innovation and developing powerful state programs in the field of tire recycling. Throughout this series, we're excited to share the insights, best practices, and success stories from a wide array of markets and applications in creating valuable second lives for these products and strengthening an already robust tire recycling ecosystem. Tire recycling is a pillar of sustainability, innovation, and economic growth in the U.S. According to the U.S. Tire Manufacturer Association's 2023 End-of-Life Tire Management Report, tires remain one of the most recycled and reclaimed products in the country. Among consumer commodities, almost 79% of end-of-life tires are put into a valuable end-use market. But an ongoing challenge we see is that end-of-life tire generation continues to outpace recycling and consumption in end markets. We believe a powerful solution is the expansion of ELT markets. Expanding markets for recycled tire products not only leads to better ELT management, but it also creates substantial economic and environmental benefits, from job creation to better performing road surfaces that reduce maintenance costs and increase fuel efficiency, to highly effective stormwater infiltration galleries with lower CO2 emissions and energy consumption. The benefits are in fact vast, and we're just scratching the surface. In this series, we will address the benefits of ELT recycling and provide suggested actionable steps and resources. We want to spur action among forward-thinking policymakers, DOT and municipal leaders, civil engineers, recyclers, and others across the broader tire value chain, so you can apply lessons learned and advanced ELT management in your own markets. On today's webinar, we'll be discussing one of the leading tire recycling markets, Tire-Derived Aggregate, or TDA, what the latest research says, its unique engineering, environmental, economic, and social benefits, and how it's been successfully applied as a high-performing aggregate material for geotechnical, structural, and stormwater uses in civil and environmental engineering projects. To help provide those key insights and real-world examples, we've gathered a distinguished panel of guests. But first, allow me to introduce myself. I'm John Sheeran, the Senior End-of-Life Tire Program Director for the U.S. Tire Manufacturers Association. I've been growing end-of-life tire markets for 11 years here at USTMA, and before that, I spent 20 years approximately at Bridgestone. Our panelists will include Dr. Hani El-Nagar from Dalhousie University in Nova Scotia, where he's the professor of geostructural engineering, and he's done extensive research with tire-derived aggregate. We've also got Tim Landers, the Midwest Regional Sales Director for Liberty Tire Recycling, the largest tire recycling company in the US, in fact, I think in North America, and he's based in Ohio. We've got Monty Niemi, the CEO of First State Tire Recycling out of Minnesota. They're a leading manufacturer of sustainable lightweight aggregates. And we've also got Joaquin Wright, the technical director at GHD Environmental Limited, who has vast practical experience with TDA. He's been spearheading, managing, and supporting the state of California's efforts to promote the use of recycled and sustainable materials in civil engineering applications. We've got a great panel and a lot to discuss today, and we plan to address audience questions at the end of the session as time permits. We ask that you please use the Q&A feature in this webinar to prompt the questions that you may have for the panel throughout the panel discussion, and like I said, we'll pick those all up at the end. The USTMA, together with our partners at the Tire and Rubber Association of Canada, Liberty Tire Recycling, and First State Tire Recycling, just released a State of Knowledge report for Tire-Derived Aggregate. And this is the title in the first slide. It's the first report of its kind to examine TDA specifically, the science behind it, and the market applications. Dr. Hani El-Nagar is the author of that report. And I'd like to take the first few minutes of our webinar today to have Dr. El-Nagar provide listeners with the highlights of this research. Dr. El-Nagar, please start us off with some of the most critical findings of this research.
Thank you so much, John, for the introduction. Actually, as you have said, TDA has unique engineering and environmental benefits, as well as other economic and social benefits, making it a perfect aggregate material to be used in various geotechnical structure and stormwater uses in civil engineering and environmental engineering projects. So for instance, please can next slide. TDA is generally less expensive than conventional materials due to the abundance of scrap tires. The process as well required to produce aggregate from them is relatively simple compared to the extraction, crushing, and grading processes needed for natural aggregates. In many cases, the cost associated with producing TDA are limited to just shredding and minimal handling, which are substantially lower than quarrying, hulling, and refining of conventional materials. Also, multiple studies have shown that TDA offers significant cost savings over traditional aggregates. For example, in embankment projects, using TDA instead of soil or a lightweight alternative such as ABS reduces the project cost by as much as 60%. This is just an example, and several projects showing the cost benefits and economic benefits of TDA in addition to its social benefits, creating jobs, and environmental benefits for sure. Next slide, please. So, as we know, TDA has several unique physical features and properties that make them great. So first, low density. TDA weighs only 1/3 of what soil does. This reduces the stresses on buried pipelines, buried culverts, buried infrastructures in general. So this is a very great feature. Second, when it comes to permeability, TDA has a very high permeability, which is almost 10 times faster than soils. When it comes to insulation, where TDA insulates 8 times better than natural soils and can increase the energy efficiency, for example, in basements, if it's used to backfill around basements and so on. Definitely, when it comes to cost, as we have said and discussed in the previous slide, huge cost savings as well. So we are getting all of this very good benefits. And at the same time, when it comes to economy, it's much more less when it compared to conventional soil. Also, a very promising application, which is the vibration control. So due to its rubbery nature, it provides a better vibration mitigation compared to conventional soil. These features make TDA particularly valuable in several civil engineering applications, like in road construction, landfill drainage, embankment fills. The high permeability of TDA helps improve drainage systems by preventing waterlogging and reducing hydrostatic pressures, thereby enhancing the longevity and stability of structures. Next slide, please. So, also using TDA to prevent frost heave damage can eliminate the ongoing expenses associated with road repairs. So this is very important. Moreover, the lightweight nature of TDA reduces the load on underlying soils, which are going to help mitigating settlement issues and making TDA ideal for use in soft ground conditions. Next slide, please. In addition, the use of TDA as a backfilling material behind retaining walls represent a sustainable and innovative approach to civil engineering, capitalizing on the environmental benefits of recycling scrap tires. The lightweight nature of TDA reduces the overall load on retaining structures, which can be particularly very important and very advantageous when it comes to seismic regions, where reducing mass will going to help mitigate earthquake forces. Next slide, please. So, as we have said before, TDA is a cost-effective and sustainable option also for stormwater management systems, and it has been applied a lot. Their large void space allow for significant water storage and infiltration, making them ideal for applications like storage, retention, and filtration. Next slide, please. So this is kind of a very quick overview of TDA, and most of you knows the great benefits of TDA. So in order to make it more accessible to civil engineers or designers in order to use it, much more details about TDA and its beneficial uses and design tips can be found in the newly released state-of-the-art knowledge report published by the U.S. Tire Manufacturers Association, which is titled "Transforming End-of-Life Tires, End-of-Life Tires into a Resource: The Role of Tire-Derived Aggregates in Civil Engineering." So this resource is very important. Basically, this book consists of 10 chapters, which includes first an introduction chapter, then followed by another chapter on the engineering properties of TDA, another chapter on geotechnical and geostructural applications of TDA, another chapter on the geoenvironmental applications of TDA, and then applications of TDA and rubberized concrete, application of TDA and vibration dampening applications. Then a chapter talking about the economics of tire-derived aggregates, then a sample of notable projects that was using the TDA, and then it just hints on the knowledge gaps and what we need in order to advance in research in order to cover all aspects of this great material. So, next slide, please. When it comes to research, what's next? So, it's very important. We know that there is a lack of standardized design guidelines or best practices for using TDA in specific civil engineering applications. So that's why we are working right now and developing such standards and guidelines. Hopefully, this will be included in the STM in the near future to be more standardized for all engineers to use the same resource and to have the same design philosophy. There is also a need for more robust guidelines on the use of TDA, including optimal mix proportion, compaction requirements, quality control measures for the integration into construction projects. Also, many studies on TDA are laboratory-based, and the field performance data remain limited. Hence, more in-situ monitoring and long-term field evaluations are necessary to validate the results obtained in controlled environments and to assess the real-world performance of TDA and civil engineering infrastructures. So this is, again, thing that we are working on, and this is the direction of research, I think, in the next few years. Thank you so much. Thanks.
Thank you, Dr. Alnagar.
Oh, you're welcome.
Thank you for walking us through those findings. The environmental properties of tire-derived aggregate, for example, are found in Chapter 2 of this report. This report can be found online at the USTMA's website by searching under tire-derived aggregate, and it pops right up. The link for this report was in the invitation to this webinar, and it will certainly be in the follow-up materials to the webinar as well. And I think we can put it up in the Q&A at the end for one final reminder of where the actual report can be obtained. While research continues to advance our knowledge and applications of TDA, there have already been many successful implementations of tire-derived aggregate across sectors. Tim, Monty, Joaquin, you've each seen TDA used in ways that benefit communities and constituents in several different ways. I'd like to get each of your perspectives about the benefits that TDA offers in civil engineering projects and what kind of projects stand out to you as highly successful. So let's start with you, Tim. You've overseen Liberty's work in Ohio for many years and now nationally as well. And according to the Ohio EPA, since the beginning of that state's scrap tire remediation program, Ohio's cleaned up more than 43 million tires. Many other states have similar records in cleaning up the old stockpiles. So let us know what you think, Tim. Let's start with you.
First, let me thank you, John, and USTMA for inviting Liberty to participate in this webinar. On behalf of my partners in this business, we just want to give you a thank you. So the history of Ohio is interesting. I mean, I think it was one of the first states that decided to tackle end-of-life tires, primarily driven by the amount of illegal dumps that existed throughout the 80 counties in the state of Ohio. Liberty, when I joined Liberty 20 years ago, we were in the midst of cleaning up maybe one of the largest tire dumps in the country. It was the Kirby tire pile in Ohio, which was on a 146-acre farm. There was 7 acres that were burnt, so they contained partially burnt tires and petroleum products, along with another 30 acres or so of tires that were stacked in what appeared to be compliance piles of 50 by 50, and everything looked great from the surface. Liberty was in the process of taking that material, and they were shredding it, and they were moving it into a local landfill, most of which just went in for disposal, but some of it was used beneficially. So throughout the last 20 years, Liberty's been the contractor of choice with the state of EPA and a partnership with them to clean up all open dumps. The majority of large and simple dumps were cleaned up early in the process. Then we got into the ones that were more difficult terrain, more difficult situations, everything from cutting tires off of trees that had grown through them to diving into the Ohio River and pulling them out stacks of 20 or 30 on a cable. So it's been quite a history with respect to the scrap tire program there. I think with relationship to TDA, it fostered a need or identified a need for tires that were not part of what we call the normal stream. The normal stream being tires that are being scrapped through retail dealers and that normal flow that would flow in. Cleanups were an additional volume that was unpredictable at the time. So seasonally, we might see increases in retail scrap tire returns. Add to that the amount of tires that we might get in a cleanup. The Kirby tire pile, although not known specifically, was well in excess of 25 million PTEs when it was finished 9 years after it began. So matching that inbound volume with outbound products as Liberty was developing its product catalog, meaning tire-derived aggregate, tire-derived fuel, crumb rubber, and ultimately into retail mulch, we were trying to balance the inbound and the outbound, and TDA became a big factor in our ability to do that. As a sidebar, I left the waste industry to come to Liberty. I was a consumer of TDA when I was in the waste industry in Ohio, using it in landfills for liner protection as well as gas wells. So it was an easy transition for me to understand some of the back end markets. And since then, I've had an opportunity to continue to help grow that catalog of products for Liberty.
So those landfill projects, the liner protection and the gas wells, are those the ones that stand out as being particularly successful?
Yes, in Central Ohio, in Franklin County, one of the now the largest metropolitan area in the state of Ohio, there is a solid waste district owned landfill, which is extremely large. It's the largest landfill in Central Ohio. They have been a huge proponent of using tire-derived aggregate for liner material. At one stage in their development, they accumulated over 30,000 tons so they could place it in a large cell construction. So it took us almost 2 years to get enough product manufactured and on site for them. It took us 2 years to put it on site. It took them about 2 months to place it. So the timing of that was certainly challenging, and one that I personally remember as something that occupied a lot of time and attention on behalf of Liberty.
So the storage issue and the timing, those were some of the hurdles that you were able to overcome using landfill projects, gathering up enough material in advance in their schedule so that they can use it on their construction timeframe.
That's correct. And the storage has its challenges because it's regulated heavily in most states, meaning how much material can I store in a particular pile? How far between piles must I maintain open space for any type of access? So it becomes very challenging in terms of being able to not only make that material over a specified period of time that lines up with a construction project, but also having adequate storage either on our property or on the customer's property to get that material on site, stored properly, and in compliance with the local and state regulations.
Why do you think this was successful in this specific application in your Ohio community?
I think it was a partnership. Obviously, the Ohio EPA, who established the rules and the guidelines, were also big proponents of us trying to find new markets, market development. Even through their grant program, they were very supportive with Liberty giving grants for us to do additional manufacturing to meet other product needs. So that was started with them being open to the idea that an aggregate material, a supplemental or alternative aggregate material, was more than suitable for a lot of civil applications. And the landfill project seemed to be one of those. So that, and we had user-friendly operators of the landfills, as well as the engineering firms that are what I would refer to the third leg of the stool. So you've got the agency, you've got the owner, and then you've got the engineering firm, all need to be in harmony with respect to the use of aggregate, because although it has all these benefits, it also has a few unique challenges, meaning a quarry can just add assets and mine more product if they have a demand. The tire business is driven by how much comes through the front gate. So balancing that over a large project like this can be a challenge. Storage is one of the ways that we accomplish that, by having the ability to store material in advance and then allow the contractor and the owner of the project to place that as quickly as possible without delay.
Thanks, Tim. And we'll come back to that that triad that supports the projects of the agency, the owner, and the engineer. But let's turn to Joaquin for a moment. Joaquin, despite having the highest number of waste tires in the U.S. at 51 million tires per year in generation, we know California has been a little ahead of the curve on adopting TDA. What range of projects have been undertaken in California using TDA, and what benefits are you seeing?
Thanks, John. And I want to echo that. I think I'm really happy to participate in this, and that sharing this knowledge in a broader outreach event, this webinar, is a great thing. Thank you for inviting me to participate. So to kind of just touch base on California's experience, California started using TDA in 2001 in their first embankment project. And in 2003, they did a retaining wall project. These were pilot projects to begin understanding. And in 2004, they began understanding vibration mitigation. And then 2007 was the first roadslide repair in California. And all these projects and all the projects that have been placed in California are all highly successful and have stood the time sequence so far, at least from 2001 to 2007. Those are two applications that are still standing and doing very well and don't have any issues. So I just want to start with that, we see lots of success. That's what we see in the use of TDA on the West Coast or in California. So some specific types of projects that have really come to mind was the retaining wall backfill, where we use TDA behind a large cast-in-place retaining walls and you use the reduced pressure, the lightweight attribute of the material, and it allows for being able to construct these large retaining walls with less rebar, and you have a safe product that lasts longer and has a seismic resilience that you wouldn't get with traditional soil. And then, so that's a retaining wall, which is also similar to an embankment fill, just on the technical side, and same kind of benefits, lightweight and seismic resilience. And then the road slide repairs, we call them slip outs. And so often you'll have locations where the road is continuously failing, meaning you do a repair with a traditional method and then it fails again. And 10 years later, you do that repair once more. And what we have found is that the slip outs that are repaired with TDA, because it's lightweight, has a high internal shear strength, they last longer, and you have less of this coming back to the site. So it's a great material for problematic road slides. And the first one in California was 2007, and there was a series of years, 2007, 2010, where a lot of them were done, and they all are performing still to this day, excellent. And those have basically tripled the lifespan of the repair. So it's something to note that we see cost effectiveness and longevity in the repairs for road slides. Then also the vibration attenuation is a great highlight of how to use TDA, and it's really that's putting it underneath rail lines, commuter lines, to mitigate the vibration that happens when the trains go over the tracks and shake the ground. And there is technology, and is technology that's been used for that mitigation, and it's really expensive. And the TDA alternative is very, very, very cost effective. And so now at this point in time, after it's been proven, since Cal Recycle actually instigated that research and showed that starting in 2004, now all the light rail institutions in California, when they do expansions and they need vibration attenuation, TDA is at the top of their list, and they use that first and foremost, and some before they go to any other alternatives. Because it's very effective, it has that seismic attenuation, and the vibration and seismic are very similar, and it's extremely cost effective. And then lastly, there are some other ones I'm not mentioning, but I want to mention the stormwater infiltration galleries that capture road surface runoff, and all the pollutants in that water go into an infiltration gallery that has TDA as the media that the volume of water is sitting in. And TDA, through some research projects that Cal Recycle sponsored, has shown that, it's been shown that the microfilm, that the microbiology, the little communities that develop on TDA develop much faster and more robust than they would on, say, gravel. And that develops communities, and those little communities of organisms are what's actually cleaning the water. In TDA, because of its properties, its carbon black and other things, its surface area allows for that to happen. And so TDA is a great media for cleaning road surface stormwater and the constituents that you might find in that, as well as, phosphorus and nitrate. And of course, the other thing about the galleries is that they capture everything that comes off the road. So in a broader sense, you're using TDA to clean the water before it goes towards the groundwater table, but also it's part of a larger type of way to control pollution from the road surfaces. So that's kind of a quick summary of the highlighted type of projects that we've seen. And again, I'd come back to this idea of longevity in these type of applications, and that, since 2001, the first project, Dixon Landing Embankment in San Jose, Milpitas area, all the projects have performed well. So it just shows you that when your engineers find the data, use the data, and design with TDA in mind, and the knowledge and the limitations, that these projects outperform typical similar projects, and have shown that in California. So I really appreciate being able to share that, to the broader broader world, that these projects have stood the test of time.
Thank you, Joaquin. You have a wide range of projects in California that are showing off a host of benefits, from the lightweight application in the retaining walls to the drainage and water cleaning properties with the additional biofilm. Monty, I know you've been building TDA markets from the ground up in Minnesota, and I'm very eager to get your perspective, particularly acknowledging that triad of stakeholders in a project that we often see: the engineer, the owner, and the agency.
Well, thanks, John. I'm really kind of humbled to be part of this group. I think back to 1981 when I was just a tire transporter and there was no state regulations anyplace. And when 84 came around and Minnesota was the first state in the nation to mandate recycling of tires, it just kind of started us on a trail of trying to figure out what to do with these tires. And so, yeah, we've been just really blessed to try figure out how to build a product out of end-of-life tires. And, we've been marginally successful at doing that for a number of years. The question you asked about building a relationship, I think the key is to have good communication, both with the regulators that have the rules in place to make sure that people are doing things properly, but also with the education with the engineers, so the engineers know what properties this material has. So when they go to look at their projects coming across their desk, what is the problem that they have in this project? They have a wall that needs to be backfilled. How do I increase the safety factor on that wall? I have a stormwater project and no property, no space on this site to put a stormwater pond. The cost of stormwater ponds, these are all factors that cause an engineer to say, what does your material have that makes a difference? And so as we have learned and worked with different universities and the work that California has been doing to study walls and vibration and stormwater, those pieces have all come into play over the years. As far as when an engineer says, what's the specific gravity of TDA? We're not an engineering firm. We're just a company making shredded tires. But as we start putting these pieces together, putting this network together, it's been very successful. As far as
can you talk about some of your TDA installations and how the TDA reduced civil engineers' concerns about soil weight or inadequate drainage?
Sure. Yeah, the first projects we did were lightweight projects. They had soft soils. They wanted to be able to float a road without having to excavate all that heavy soils. And so they would come in with our lightweight material and build a foundation for the roadway, put 18 inches of soil over the top of it. They'd have a very good driving surface. And so that was back in 86 when we first started doing those first lightweight projects. As we started doing other lightweight projects, the material would be delivered to the job site, and the contractor would be taking it and placing it. And the engineer came up to me and said, look at that material. It's standing vertical. That angle of repose is almost vertical. He said, I bet you this would really be good for behind retaining walls. And so all of a sudden, that whole concept of using it behind walls came because just seeing the practical nature of this material and how it behaves. When we started looking at what the unit weight was, and we started looking at what was the void space in this material, and all of a sudden we recognized it had a 50% void space, and they were trying to calculate how fast the water would run through it. All of a sudden they're saying, wow, this is 10 times faster than soil. Boy, this is really great for compared to granite or anything else that's only 25% void space. This has 50% void space. If we wanted to store water in this underground, that would be a really very efficient material to use. And so this just little baby steps of looking at what the properties are allowed engineers to say, I got a problem, I would like to try that.
So you've described a track record of successful TDA applications, but they also save the property owners dollars.
That's the bottom line. These designers, these people that have these projects coming across their desk, they're trying to give their client options on how to build on their site. And they also want to give their clients options on what the cost effectiveness of the different options are. And so when TDA comes into the picture and it has better engineering properties and it comes in at a very low cost, and it's had to prove itself that it can deliver in a timely manner to the construction cycles of the contractor, deliver it fast enough, have enough material when they need it, be able to do the cleaning up of the job site afterwards if a contractor isn't handling the material properly. All these little pieces make a difference. But yes, cost savings to the engineer, having that project be a feather in his hat when it's done, when the governor gives an award for a project for its excellence in recycling or get written up in some journal, these engineers recognize it's their hard work making something out of these end-of-life tires that's solving somebody else's problem at a cost savings.
Absolutely. So staying with TDA's unique properties and applications, let's talk about the importance of the use of TDA in that stormwater mitigation application. Joaquin, can you touch on the stormwater mitigation application from your perspective?
Yeah. Well, the stormwater application, so I would say has so many benefits because the TDA has this high ratio, meaning it can hold lots of water, like Monty was describing. And so it's a better material than, say, gravel, which is typically utilized in terms of these types of designs. And then it has this added benefit of actually developing a community to clean the water of microorganisms quicker than any other material. And what some of the research that's happening now is also showing is that these galleries are also mitigating lots of concerned constituents that people are concerned about. And so what you're doing is you not only are you reusing TDA and finding the benefits from it, but you're also taking this road surface runoff, which is an issue in a broader perspective. All the things that are coming off, microplastics and everything else coming off of the roads, and then you're adding a recycled material into the stormwater gallery that is bringing all this benefit. It's like a double benefit. It's got a lot of more volume, and it's cleaning the water before that water infiltrates towards the groundwater setting, which is a big topic in California. So these galleries, to me, are the wave of the future because of these benefits that really only come from TDA.
Thanks, Joaquin. And Monty, do you have anything to add? I know you've got a specific expertise in this space. In particular, could you talk about the importance of implementing TDA material as part of innovative engineered design concepts in the real world, something you've had a lot of success with?
Thank you, John. The St. Paul Port Authority calls this material the next stormwater aggregate, this next stormwater solutions, basically because of the cost savings and the uniqueness of this material. This material, through the work that MnDrive and the University of Minnesota have done, show that the TDA and the biofilm does not leach any of the metals back into the environment, and yet it can remove up to 95% of the phosphorus that flows through, besides the nitrates and pesticides and petroleum products. And so these engineers and these communities are saying, I got a problem. I want to solve my water storage issue. I want to be able to keep my lake from turning green with algae. How do I do that? And TDA is part of that design solution that is making a difference.
And Dr. El-Nagar, sticking with stormwater, what does the State of Knowledge report offer about the effectiveness of TDA?
Okay, this is a very good question, actually. So in the report, it's being discussed in details, but we can summarize here today. TDA is considered an effective stormwater drainage medium due to its high permeability and resistant to clogging. So for instance, TDA hydraulic conductivity is about in the order of 1 to 2 centimeters per sack, which is very comparable to coarse gravel. So this is a very good feature in this regard. Also, the hydrophobic properties of tires make them effective absorbents when applied as a part of engineering concepts, which helps mitigate the migration of contaminants into the surrounding environments. We can also say that studies on urban storms infiltration, and this is actually being in the State of Knowledge report. There's chapters talking about this. Galleries using TDA have shown that reduced concentration of heavy metals and pollutants, which not exceeding of the primary drinking water standards. So actually, there's very useful applications, lots of design tips and background research that's available in the State of Knowledge report.
Thank you, Hanny.
You're welcome.
That's focusing on the stormwater application, but still sticking with drainage. Tim, in landfills, you were describing liner protection at the base of the landfill where the TDA acts as the leachate collection system?
Correct. Yeah, landfills,
You're muted, Tim.
So landfills, when they're under construction, are putting down a clay liner, and then on top of that, they'll put a synthetic liner. And then on top of that, they're required to put some type of protective layer and drainage layer combination. In most cases, we're able to supplement that with a couple feet of a rubber product. It usually is a little bit smaller than, it's very similar to a fuel size material that we produce as part of our catalog of materials. So it's roughly a 2 to 3 inch shred that goes in. Contractors who have never used this material before start out with some reluctance, but once they start pushing this material and placing it, they find out that it has other benefits that they didn't understand. You put sand or gravel on the slope of a plastic liner, you'll find out just how difficult it is to keep it in place. The rubber stays put. As you're pushing it up the side slopes, it stays in place, and they're able to do that much easier. It also provides that frost protection we talked about earlier. So if you're late in the fall in the upper Midwest and you're getting ready for a freeze cycle, getting that thermal value on top of that liner to protect that clay so its integrity is not compromised is extremely important. So that's a function that that's difficult to translate when you speak to someone about it, but once they've been engaged in a project that's used that type of media for their drainage layer, most of them are repeat customers at that point.
Very nice. Most of these applications of TDA highlight very key benefits that the material provides. And we might start by thinking tire-derived aggregate is just shredded tires, but it's a lot more than that, because not only the host of benefits that it provides, but it's manufactured to ASTM standards for TDA. And we have two manufacturers on with us here today, both Tim and Monty, manufacture tire-derived aggregate. So could you talk to us a little bit about the ASTM standards for TDA and what are their chief objectives?
So I'll just make a brief comment. One of the things that I appreciate about being able to refer a client or an engineering firm to an ASTM document adds credibility to the process. If I give them literature that's produced within the Liberty organization, it can be self-serving. So to be able to refer them to ASTM and tell them that they identify two types, a type A and a type B. Type A is what I described a few minutes ago, roughly a 3-inch chip or smaller. And then a type B, which can be as large as 12 inches. Those applications, those installations, and all of those benefits of using that material is all spelled out in ASTM, which is very beneficial to educate an owner, an engineering firm, and in some cases, even a client.
And Monty, I think you were part of the rewrite of those standards just a couple of years ago. What are those guidelines doing for your business?
It's really been a blessing to have this ASTM 6270 in place. When we've done over 400 installations using TDA in construction, and as we document those projects and we have a continuing education program where we go into engineering firms and explain how these materials been used, we can kind of show what this ASTM is and how that material is the same as what's being done in California or the same as it's being done out in Maine. And so it's really very much unifying the customer so they understand what material is going to show up on their job site, and that each material that shows up doesn't have to be retested or re-verified if it's going to work or not. And so this ASTM has really brought a lot of stability to it, both from a state, county, even township, and private parties want to know that they're not getting a lemon of a material, but they're getting the same material.
And these ASTM standards describe exactly what it is so that you can purchase it repeatedly.
Yes, that's correct. The ASTM has been designed very efficiently to be able to describe the material that comes through our process, or these types of processes.
Thanks. Dr. El-Nagar, this descriptive nature of the standard gives engineers an ability to specify it pretty easily, and you're educating these engineers. What do you see the value of this standard?
So I see the value of the standard as it's one place which is collectively all application or most applications of TDA with their properties, different properties, the literature background of all of the properties and all of the informations inside this state of knowledge report is all in one place. So this makes it easy for engineers to adopt the material and to educate themselves on the different aspects of the material and the different beneficial uses of the material. Because we know as engineers, we need first to be confident that we are able to design the project using the information available to us. So this kind of state of knowledge report acts at this bridge where engineers are going to educate themselves, and accordingly, they're going to feel comfortable designing and stamping on designs using TDA. So I think it's very important to them. It's very important first step, let's put it this way.
Thank you.
To engineers. You're welcome.
So the standard provides a foundation, and the State of Knowledge report provides the application. Turning specifically to the cost benefits of TDA, Joaquin, what notable cost savings are attributed to TDA use?
Well, very specifically, when you're looking at repairs, civil repairs, roads, embankments, anything like that in that nature, you're looking for a material for that project, regardless of what material you choose. And when you have specific needs like lightweight, then generally that material is going to be imported to the site, and that's a very costly thing. And when you're in that as an engineer or a professional looking at that project, the cost of transporting and getting TDA is usually much more cost effective than the comparable materials, pumice rock, foam, etc., different types of lightweight material. And so that's where we really see a cost benefit. That cost benefit actually kind of grows when you go into the designing, in that when you have a lightweight material, we talk about geotechnical perspectives, when you have a lightweight material that has high internal shear strength, high internal strength like TDA, then often the design itself can be different, and you can limit the amount of excavation needed or these other large costly components to civil road and embankment and retaining wall construction. And so it kind of compounds on itself. First, it's very cost effective because you need to import lightweight material, and TDA is I would say 99% always the most cost effective of those types of materials for importing. And then on top of that, that allows a designer to choose different alternatives which don't have as much other costs like excavation. So that's a kind of the general way in which we see the cost effectiveness play out with TDA in projects.
I see. And Monty, how would you add to that?
So I would add to it, if you're right now, I'm just working on a township project where the township has a road going through a low area, and the cheap option is just to put another 6 inches of class 5 on top. They've been doing that for the last 20 years, and it keeps settling. And so all of a sudden, when the engineer is telling them, let's remove all that heavy material, come in with your lightweight material and fix it once, so you don't have to pay year after year for this material that's settling into the swamp. So it is really a material that when you deliver 80 cubic yards at one delivery to a job site is hands down better than soil can be delivered. and it solves the problem long term versus just getting over the hump kind of situation.
Tim, anything to add?
Actually, I think they covered it very well, so I won't belabor the point. I think that both Joaquin and Monty covered it very well.
Thank you. I want to fold into the discussion some of the current challenges associated with TDA use. So let's bring it back to Dr. El Nagar to talk about some of the gaps in our research where we need to continue improving our understanding of TDA markets.
Yes, thanks. So basically, as we have said, we need to verify all of the results that came from laboratory basis experiments. So basically, the full-scale testing, we need to monitor for long term. We need to measure, we need to compare the performance in the field that was what was assumed or adopted during the design. So this is very important at the stage right now to try to document as many as possible different cases. So let's say, as Monty said, he was involved in 400 different installations. This is the wealth. So if we are able to validate as much and as many as possible from such projects and make sure that our knowledge, current knowledge, and our design methods is working fine as per the long-term performance of the projects. This is very important. This is very important to be documented because in this session today, let's say we are 200, but we have thousands of other engineers that designing such things. So we need to have a resource documenting this for them to relate to. So when they do their design, they reference it in their design. They feel more comfortable knowing the long-term performance of the structures that being designed similarly to what they are anticipated to adopt in their designs and so on. So this is a very important thing. So let's say what we need right now, we're going to take all of the lab scale experiments that was done, let's say in the last 2 decades, which is so many. And right now we have this wealth and this kind of assets of the projects that already being implemented in the field and start validating the different concepts, try to verify and try to maybe tweak a little bit things as per the site performance. So I think this will be the direction of the research in the next decade. Myself, I'm looking into this right
Thanks,
now.
Andy.
Europe.
So to our panel as a whole, I'm interested in everyone's thoughts on this. What are you doing currently to expand your work with TDA, and how can we help civil engineers and others design with confidence when using this material? Who wants to take it first?
I'll comment first. We, from Liberty's perspective, I've commented a lot about what I would consider to be larger products, and I think larger projects, and I think in some sense Monty's spoken in the same manner with respect to retaining walls and large backfill road projects and landfill liners and all that. But in most of our operations that we have over 50 in North America, we're also focused on what we refer to as the gate customer, the person that comes in that runs a septic tank business that is coming in to get that material for the leach bed. It's a fantastic material for them to use in the leach field because of all the properties we just talked about. In addition to the fact that if a guy's got to run it out there with a wheelbarrow, he'd rather take our rubber chip in a wheelbarrow than he would sand or gravel. So you've got those folks that we try to communicate with the local health departments and make sure they're on board, they approve it, and they're going to permit the use of that material. And then we start to reach out to try to create that opportunity for someone to come in and get an alternative product to what they might normally propose. The same with backfill on home foundations. You'll find builders that use it once and then they'll embrace it from that point forward. Small in volume, but can have a tremendous impact if we can grow it exponentially.
Monty, I know you've done a lot of work to expand the TDA markets. What have you been doing lately?
Well, pre-COVID, we had a continuing education program we brought and to engineering firms, and we had over 1,000 continuing education certificates handed out. Most recently, we've got probably 150 certificates that we've distributed to the people that have sat through an updated TDA course with some of the most recent science. Right now, it really is a word of mouth. So when we do a project, we invite all these engineering firms that we've shared with to come out and see the projects, do a show and tell, get them comfortable with it. Again, follow up with the people that are designing projects, making sure that new stuff coming across their desk, that they're having good experiences so they can continue to use the material. Now and then we end up putting little flyers out that there's a special because we're getting full in our inventory, and that makes a difference sometimes too.
Joaquin, anything to add?
I would just say that I think the perspective here is we've heard, is that more study, more knowledge, that more verification of the long-term viability and performance only helps to educate the folks that have doubts and questions. And so the more of that we can do, the more studying we can do on the knowledge gaps and present that to the wider engineering audience, the better. And I think that's a direction to go here.
Thanks. We're going to get ready to go to questions in just a couple minutes, so keep them coming in through the Q&A. I know we've got a couple already lined up, but for our panel, I've got one final question before going on to all of our audience questions, and this is for all four panelists. So for our attendees today who represent state government or state DOTs, or who are civil engineers, and more, what's the best advice you would have for them to identify opportunities to use TDA and advance TDA markets in their spheres of influence? So let's start with our professor, Dr. El Nagar.
So I didn't get exactly what you can just. Yep.
For our attendees today who represent state government, state DOTs, or are civil or environmental engineers, what's the best advice you have for them to identify opportunities to use TDA and advance TDA markets in their professional spheres of influence?
Okay, perfect. As Monty said, launch and learn is a very important thing. So if they can put their hand in our hands and working together for such events of workshops, launch and learns, wherever, nationwide, this will be very important for all of their engineers and the engineers involved in the industry to get familiar with the material, to get familiar with the benefits of the material, and to start getting some leads for themselves to educate themselves. So working together with them is very important. This is the only way ahead. This is the only way forward, that we work together, educating each other, helping, providing the resources, providing the avenues needed for engineers to get familiar with the material, to get more confident with the material. So we want to work with them. This is very
Thank you. Joaquin, where do we find these kind of opportunities?
Well, I think that the basis of it is to have an understanding of TDA, the material properties and the benefits that it brings. That allows you to identify areas where you can perform or build a better product for your client by knowing the material properties. And I'd say that most engineers don't. They go a traditional route. And so getting that knowledge out to engineers to be knowledgeable about the properties of TDA, because that's how they're going to look at this from design perspective and understand the benefits, and then they can see the cost benefits as well as the design benefits, and then become the champion for that use because it makes sense to them. So I guess that's an education component. That's where I see the way to help with TDA use, is by educating the users on the properties. And I would say that also to add to that is that, that's a very dry, very engineering perspective, but from other professionals who are involved, and there are a myriad of them, it's not just an engineer involved with a project, using, a civil project, is that there are social benefits too. There are what we call soft benefits for using recycled material, for not using, mining resources. And to be familiar and understand those too, then we really can understand the benefits as a whole that are coming when we look at using TDA as an alternative material.
Thanks, Joaquin. So know the material, know the benefits. Tim, what would you add to that?
Yeah, I would build on what we just heard, and that is that call it a soft benefit. But when you think about what an end-of-life tire as TDA offers, it offers the use of a waste resource, recycled resource, versus a natural resource, which has limitations. So if we're mining aggregates for projects that we've been talking about for the last hour or so, that has a limited life. I mean, that has a limited limit to how much is out there. When we're talking about end-of-life tires, are generated every day. And although
Right.
we have a myriad of products, it is one that Liberty focuses on as something that would always be sustainable in our book of business. So to look at it as reusing a resource that isn't going to be depleted as sand or gravel would be, I just think it's one. If you want to talk about being green, this is one of the ways that I think you can really step out and lead.
Yeah, I would just
Monty?
add, can I just
Go ahead,
add to that
Joaquin.
before,
Please.
not to, is that, when we think about the word sustainable, most people have some kind of vision in their mind. But when we're really just pragmatically looking at that, a material that is going to continue to be available is a sustainable material. And TDA fits that definition. There's no place in the future, foreseeably near future, where we're not going to, be replacing tires on our vehicles. And so we're going to have this material, and it's a sustainable thing you can build with for the foreseeable future. Thanks.
Monty, any closing words to that question? Any proven roadmap or most important elements that you want to underscore?
Well, I think it's critical to recognize that engineers are risk adverse, and being risk adverse, the problem comes across their desk that they're having to review. They go back to what they've done for years, the same old solution. And so we have to have the engineer say that old solution works, because obviously they worked long before TDA came around, but now TDA can work better or as good for cost less. Sometimes that moves the engineer into a trial stage or a demonstration project or something, but sometimes it takes the recycling coordinator down the hall to say, hey, we should be using recycled materials, and remind that engineer that this is a full circle program for the community, for the county, for the state, that her job is to find end markets for these materials. His job is to not have any problems. Well, all of a sudden now he's nudged a little bit more into trying a project that he maybe was cold on at first. And there's been some good track records of success in that because of those efforts.
Thanks, Monty. We've had a great discussion here, and we've had a strong technical team supporting us throughout the project. I want to thank Amelia Chuchalowski and Roland Bourben, who have been helping us put this webinar and the whole webinar series together. Throughout our discussion, members of our audience have been sharing questions for the panelists, and we'll run through some of those now. If we don't get to all of them, we'll make sure you get your answers addressed in the post-webinar resources that we send out. So, Amelia, what is our first question for today?
Thanks, John. Can you please comment on the potential for self-heating of TDA embankments and how ASTM D6270 addressed the issue? Yeah,
ASTM does address this issue in 6270, the standard. And Dr. Elnegard, are you familiar with this self-heating concept and how it's addressed in the standard?
Yes, yes. So actually, this was addressed in the standard where the standard asked for you don't use any layer thicker than 3 meters thick, which is 10 feet. So if you have more than that, you're gonna have a layer of separation between them, which is at least 18 inches in between. So you can have multiple layers. But in the vast majority of projects, you don't need layers thicker than the 10-foot thing. So actually, this is not a great issue right now. And we haven't seen any problem when it comes to self-heating in the last, let's say, decade or so. We haven't seen any. Monty, have you noticed any in any of the 400 projects that you?
No, Hanny, we've done a number of projects where they've been 20, 30 feet, and as long as we put the soil separation layer at the 10-foot level, we've not had no issues. I believe Joaquim has done research even on this subject to try and make it happen. Anything you can share with us, Joaquim?
Yeah, there is a research paper that's available at CalRecycle's publication website, and it was a research project to look at this. It was more specific to levee, to water infiltration and retreat, water coming in and out, and then looking at the temperature change. And I mean, the bottom line is exactly what everyone said. If this guideline at ASTM that's shown in ASTM D6270-25, which is the latest version, the 10-foot mark where you put a couple of feet of soil as a potential heat sink in case something like that happens is valid. All the projects we've done that have multiple layers, and we've had temperature sensors and things like that, and we have not seen any issues. And then when we did a test specific to this water in and out, it was the same thing. The steel belts rust at first, and they can produce a little bit of exothermic heat, but it's very minimal. And it doesn't take it anywhere near an issue. And then as long as you have that 10-foot layer, it's just, it hasn't been an issue. We've studied it, didn't see the issue, and we've built with it and haven't seen any issue.
Thank you. So it is, I'll just sum it up by saying it's a real phenomenon, and it's addressed in the ASTM standard, 18 inches of separation between 10-foot lifts, and you're good to go. But any competent engineer who can read the standard would guide you correctly on that. Amelia, can we go to our second question?
Yes. Can the panel address how they collaborated with their state agencies, like state DOT, state environmental agencies, to drive outcomes using TDA? Like, how did they collaborate and the states work together?
Monty, do you have some insights on that?
Yeah, basically, we're needing to work with whoever the user is, if it's a private party or if it's a township or county, and address their issue. Bring in the regulatory folks from the both either the county or state or the DNR, and have them all understand what the problem is and how this material solves those situations. It is very much a one-on-one situation where we have to teach the regulator why this material works and what the safety is of the material. That's where a lot of the work California has done has come in successfully over the last 15 years. It is just not being afraid, but taking each person in the right role and the right set of government situations and bringing them to the job site to make it all come together.
And Tim, you've worked with regulators in Ohio. How have you worked with them?
Part of it is just what Monty was talking about, but we saw a tremendous improvement when other states were willing to share their information with respect to projects. Monty mentioned that Minnesota may have been the first one to have a scrap tire program. I know Ohio was early in the game as well. When they were able to network and start sharing what is success they've had with just keeping tire dumps from growing and keeping tires in Ohio, to keep tires out of landfills. To this day, you cannot put a whole tire, or you can't put a tire shred in a municipal landfill, sanitary landfill in Ohio without explicit permission from the Ohio EPA stating that that tire is too dirty and cannot be processed. They were willingly part of the solution, because they had instituted these regulations, and doing so, they realized they put a burden on folks that were collecting tires. So from the very beginning, my experience has been that they were hand-in-hand partners, willing to utilize the state fees to fund with grants research and development opportunities, amnesty cleanups, in our case, helped us with some equipment purchases to move our product up the value chain and try to avoid landfill disposal or the need for a landfill disposal. So for us, we've seen it in most states where we have a significant market for TDA. We've seen that hand-in-hand opportunity without a whole lot of resistance.
So the regulators can talk to each other through the Scrap Tire Work Group, which is an unincorporated association of scrap tire professionals and regulators who oversee the end-of-life tire industry. I know they've got a tire-derived aggregate committee that focuses specifically on this. California has been working with tire-derived aggregate for many years, and Joaquin, I know you've worked with them successfully in the past.
Yeah, California has a robust program. They've supported research, a lot of great research. They have a grant program to support users that want to take that step and have a lot of successful projects. And, you know, as far as working with regulatory agencies, you know, California has a great agency in terms and a great perspective in terms of reusing tires and trying to find, you know, these avenues in TDA and other uses as well. So if you have an idea and you're in California, and even if it's not something that's in their standardized understanding, you know, they're open ears, and that I think is maybe the greatest thing you can have, is just the ability to communicate with the regulator about, you know, how and what you may want to do with the waste tire product.
Thanks, Joaquin. And let's go to the Great White North for our last insight. Hanny, how have you been able to work with the department in Nova Scotia?
Oh, perfect. I worked actually on several projects here, a kind of trial projects and kind of research projects and real projects here with the Department of Transportation here in Nova Scotia, and as well as the Department of Transportation and New Brunswick as well. And my research team is very open to collaboration with the 50 different Department of Transportation down the states. So we are very open here to have collaborative research, to work together hand in hand, and try to address all of what we need to address in order to push this very, very good material. And I look into it, not only that it is a recycled or waste material, no, it is a beneficial material. It is a product that has very useful applications. So that's why I'm very open to collaborate with all of the states, all of the departments of transportation in the states, and different projects in order to address this and to push the boundary further, because it really deserves to.
I want to share my sincere appreciation and thanks for our panel for a great discussion, and to our listeners for their insightful questions. Finding pathways to collaboration and innovation in ELT recycling is critical to reaching 100% tire circularity, so your time and attention is extremely valuable. Keep your eyes on your inboxes in the coming days, as we'll be sharing a post-webinar toolkit to help equip you even further with data, insights, and tangible steps to take to catalyze and expand TDA markets in your area of influence. I'm also excited to introduce our next webinar in this market series, which will take place at 2 o'clock Eastern on October 30th. Alongside another fantastic panel of leaders from the molded products industry, I'll be breaking down how these innovative tire-derived materials are enabling development of more durable, sustainable, and cost-effective solutions through strategic partnerships. Panel and registration information can be found at ustires.org/webinars. I think it's the code in the corner there too. Also, please take note of the Tire Recycling Foundation's 2026 Tire Recycling Conference, which will be held May 12 to 14 in Denver, Colorado. Registration is now open, and this is an excellent opportunity to engage with our esteemed panelists from today and other subject matter experts. We truly hope we will see you there so we can continue these important discussions and provide valuable information and insights. If you have feedback on the webinar or additional questions for USTMA or any of our panelists, please reach out to A. Chuchalowski at ustires.org. That is ACHUCHOLOWSKI at ustires.org. And thank you again for your attendance and attention to this webinar. Thanks, guys. Have a great afternoon.
Thank you.
Thank you, everyone.
Thank you.